He's in charge of leading a team of data scientists to build predictive machine learning models to forecast key financial measures in order to add stability and predictability to the company's P&L. June earned a BS in Computer Science and Economics from University of Toronto and an MS in Finance from University of Illinois at Urbana-Champaign. He is also a CFA charter holder and a host on the Value Investing podcast. We ask if you could please hold questions to the end for this presentation, and please welcome to the stage June Kim.
Good?
Yeah.
Thank you. Imagine you know how much revenue that your company is going to make over the next 1 year. Imagine you could know that information not just at yearly level, not just at monthly level, but at daily level. Imagine you could know that daily information by business unit, by product, and by client. Imagine you could do all that complex things and will be able to communicate the results with senior leaders who do not have an understanding about machine learning with just click of mouse. That's what I have done over the last 3 months, and that's what I'm going to talk about over the next 1 hour. So who am I? So I'm a director on the Finance Decision Science team, and I lead a team of decision scientists to tackle problems related to machine learning and big data at American Express. And I consider myself to be a person who possesses 2 skill sets, computer science and finance. On the computer science side, I have bachelor's degree in computer science from University of Toronto. And I use Python, PySpark, Power BI, all these different tools on a daily basis. On the finance side, I have a master's degree in finance. And also, I am a CFA charter holder and also a host on the Value Investing podcast. So if you guys want to listen to Value Investing podcast, then you guys can go to Google and just type in Value Investing podcast. The first or second link is going to lead you to the website. So enough about me. So let's get started on today's topic. So what am I going to talk about? So I want to discuss how you can tackle time series problems. So I'm going to tackle this problem, and I'm going to talk about, at a high level, 2 different things. Number 1, I'm going to talk about how you can transform data set so that you can insert this data set into typical machine learning models like TDM, random forest, and KNN. The second topic that I'm going to touch upon is going to be time series models. So these are the models designed for specifically for time series problems, and that's what I'm going to tackle. Those are the 2 high-level topics that I'm going to touch upon today. And focus of today is not going to be on model theory, statistics, and mathematics behind all these algorithms, but I'm going to talk about specific applications of these models and how you can use these models to solve your business problems related to time series. So with that said, let me just move on to the next slide. So I just want to define what time series is before talking about all these models. And as you can see, I have 2 examples here. But basically, time series is a sequence of data points that measure the same thing over time. So here we have S&P 500 stock price. So we are measuring S&P 500 stock price over time and US unemployment rate over time. So there's a specific challenges related to time series problem, and that's what I want to talk about first, and what they are and how you can cope with that problem. So that's the first topic, how to use machine learning models like TDM for time series data. Here's the challenge. Let's assume that you have 3 car members. These are hypothetical car members, and you are trying to predict their spend next month. This is future data. You know their credit score, credit line, and spend information in the past. But the problem is, once you're trying to use these X variables in order to predict Y variable, we don't have future data information right now. So we don't have X variables known in advance. And we are trying to predict Y variables based on unknown X variables. So this is the challenge that you're going to face when you are trying to develop time series, not time series, but machine learning models for time series problems. So let me just pause here, and I'm going to give you 5 seconds to think about your solution, and I'm going to walk you through my solution later on. Okay, so let me walk you through one potential solution that a lot of people come up with when they first face time series problem. So what people usually do, since we don't have X variables, right, known in advance, why not just forecast them first and then insert those forecasts into another model to forecast Y variable? So this is typically what people come up with when they face with time series problem and when they are trying to use machine learning models like GBM for time series problems. But there are two big problems with this approach. Number one, you have to involve multiple forecasting steps. So if you're forecasting one time and then plug that forecast into another model, then that's going to lead to higher errors. Number two, you're not considering previous spend here. You're not considering previous spend here to forecast future spend. This is quite important for any time series problems because think about your situation. So you spent, let's say, $5,000 last month on your credit card. It's likely that you're going to spend approximately the same amount of money this month. That's how people behave, and you want to capture that kind of spending behavior. So this is one potential solution, but it's not recommended. So let me go to the next slide to talk about recommended solution. So here what I'm proposing is to use lag variables. And instead of involving multiple step forecasting, you can directly use lag variables in order to forecast future spend. Then you don't have to get into this multi-step forecasting. So for example, you can use 1 month lag variable, or you can use 12 months lag variable to capture yearly seasonality because last month's spend is relevant, but also last year's spend in exactly the same month is also relevant. Because people tend to spend a lot more during December because there's a holiday season, and you want to capture that. And also you can use average variables like last 6 months, 12 months, and 3 months, because you want to sometimes remove outliers. And also you can use year-over-year change variables. And there are many different things you can do. But the bottom line here is to use lag variables in order to avoid some of the problems that I discussed on the previous slide. But there's another challenge. Okay, so if you do that, then the data set is going to be similar to something like this. So you have average here, and 1 month lag credit score, and average spend 6 months, 3 months, and also spend lag spend variables here in order to predict this February spend. So this is one way to cope with those two problems that I mentioned, multi-forecasting steps, and also using Y variables directly, lag variables directly. But let me just give you another challenge here. So what if we want to forecast 12 months spend in the future, not just 1 month data point, but you want to forecast 12 months spend, then you need to predict 12 data points, right? Then we are facing the same question. Should we plug February spend here into another model to forecast March spend and plug March spend to predict April spend? Then it's going to involve also multiple time series forecasting. So we want to avoid that, as I mentioned. And let me give you 5 seconds to think about it. So proposed solution that I have here is one of, I think this is one of the best solutions. There could be a lot of other solutions. But one proposed solution here that we came up with as a team at American Express is to create distance to target column. So what it essentially does is you have all these leg variables, and for each car member, right? Car member 1, we repeat the same thing 12 times in order to create this distance to target variable and this distance to target column. And we know this 12 months span, and we can plug this data set into GBM or any typical machine learning models. And what's going to be important for the model is this distance to target. And this is one of the many solutions, but I think that this is one of the best solutions out there. And as I mentioned, you can potentially create 12 different models to forecast these different spans. And there could be other ways you can tackle this problem. As I mentioned, you can plug forecast into another model, but that's could be disastrous in terms of having higher error rate as time goes by.
So your final solution is like have around 12 different models. Model 1 is one horizon, the second model is...
No, I think the question is whether I have to create like 12 different models. The solution that I'm proposing here is create this data set and then create this distance to target column, and then just have one, let's say, GBM model. And GBM model is going to pick up this column as very key and most important variable, because everything else is the same here, right? And this column changes over time, and it's going to predict the span related to this one specific car member. So we can have one data set that can be plugged into GBM model, and you can predict each car member's span over the next 12 months. And I'm going to have Q&A session at the end, so if you have questions, then feel free to ask after the presentation. Okay, so now we talked about how you guys can use GBM model and KNN, all these typical machine learning models for time series forecast. The next thing that I want to touch upon is actual time series models and how you guys can use time series models and how I use the time series model for my team. So for that, I pull data online from Kaggle website. This is store demand item forecasting. And this data set is panel data, which has like timestamp and also store ID and item ID and number of items sold. So we are trying to predict this number of items sold for this specific retail company. And for this exercise, I'm going to use ThreeMax model and profit model, and everything is daily, but I'm going to do some data manipulation later on, and also I'm going to use the first 4 years of data for training data set, and the last year for 1 year for test data set. So let's try to understand how this time series is. So if you look at this chart, what I did is I just aggregate everything to company level and then try to see if there's any seasonality and trend. And as you can see, there's like slightly upward linear trend for this time series data. And there's a clear yearly seasonality, right? And there's clear weekly seasonality. So so for example here, like people tend to shop a lot more for this specific retail companies during summer compared to winter time. That's what you see here. And whenever you see it's clear seasonality and also upward trend or any trend, then you can think about how you can use time series data, because time series models are designed for these specific problems. I'm going to walk you through the details for the 2 time series models that I'm going to discuss. So first one is ThreeMax model. So how many of you guys are familiar with time series models? Okay. So probably the first thing that you guys learn is ARIMA model, because that's typical time series model people study. So ThreeMax model is extension to ARIMA model, where we are incorporating the seasonality and also exogenous variables. But if you remove these two words, then it's basically ARIMA model, right? So you can capture trend, seasonality, and exogenous variables. And as you saw from the previous chart, if you see the clear trend and seasonality, then ThreeMax model might be a good fit for your problem. Let me just move on to the next slide and walk you through how I built a ThreeMax model for this specific problem. So we had daily time series data set. What I did is I simply aggregated everything to monthly level, because think about it, the problem that we are trying to solve is to predict how much this retail company is going to make over the next 1 year. And if we want to forecast daily data points, then we have to do the forecasting for 365 data points. That's a lot. So ThreeMax model doesn't work for that many forecasting steps. So for ThreeMax model, I aggregate everything to monthly level. And for just illustration purposes, I also aggregate the data to company level. So once I have this data, the next thing that I did is capture days mix. So what is days mix? Why is it important? Because you saw the weekly seasonality from the chart, right? So people have different spending behavior depending on which day you're in. So we want to understand for each given month, how many Mondays, how many Tuesdays, how many Wednesdays we have within that month. Because people tend to shop maybe a lot more during weekends or less during weekdays, so people have different shopping patterns. So that's why I'm including this Monday through Sunday as exogenous variables that I'm going to plug in later into ThreeMax model. ThreeMax model has this visualization package. So what I can do is, if you look at this top panel, this is just observed data. And you can break this observed data into 3 components: trend component, seasonality component, and residual component. And if you add these 3 panels at the bottom, then it's going to add up to this observed. So this is a good thing to show to non-technical people, because they're trying to understand how this observed data is broken into. And you can say that this is the trend component and this is seasonality component. People will get it right away. So this is, I think, good for communication purposes. The next thing that you have to do is a parameter tuning. Traditionally, if you use ThreeMax or any ARIMA model, you probably look at autocorrelation chart or partial correlation chart and trying to understand where the shape of this chart changes, and then try to determine the best parameters for PVQ. I'm not going to go into the details, but what I'm proposing here is just simply use ARIMA function within Python or R, because it's going to give you the best parameters for this specific model. And if you have to build a lot of time series model, which I'm going to talk about later, then this is a better way, instead of just looking at all these different charts, to understand what's the best parameter. And also, it's that manual approach is more error prone. So this is what I recommend. Just plug it into ARIMA model, and it's going to give you this best parameters for this specific model. The final one is you can choose whatever evaluation metrics you want. So for example, you can use mean absolute percentage error or root mean square error, and you can do the visualization using tools like Power BI and Tableau. So that's how I built a ThreeMax model, and this is kind of the performance. So you can see that this is monthly data, not daily. I built the ThreeMax model. Seems like it's below, it's under predicting the actual number for this specific train test data set. And if you look at here, the dollar or percentage difference, then it's less than 5% overall from March to all the way to December. And we have some errors here. But given that I just built this one, and I didn't even do the parameter tuning or feature engineering, I think this is relatively good performance. And it can capture, if you look at the this chart, it captures the seasonality. Seems like it's capturing the trend here. So it's relatively good. So this is ThreeMax model. As I mentioned, it captures seasonality and exhaustive variables. So this is a good starting point. You can use and build ThreeMax model very fast within 1 hour and use that as a benchmark for more complex models in the end. So that's what I recommend. So now let's talk about profit model. So what is profit model? Profit model is a time series model developed by Facebook and became open source early 2017. So it's relatively new model, not a lot of people know, but this is a really strong model that I recommend for daily forecasting. So let me just walk you through some of the pros and cons associated with profit model. So it allows daily forecasting. I mentioned this point when I talked about ThreeMax model. So not a lot of models can capture daily forecasting. Even GBM. Let's think about the example that I gave to you. I was creating this column called distance to target, and I had to replicate the same records 12 times. But if you imagine that you have to do daily forecasting 365 days next year, I think that's going to be a huge data set that you have to create for GBM, and as time goes by, your error rate is going to go up. But profit model can capture this data and also can do the daily forecasting very well. So that's what I prefer in this specific case. And also the second thing that I want to mention is holiday effects. The package is designed to capture holiday effects very well. So for example, let's think about Amazon as an example. So Amazon has Prime Day, Amazon Prime Day, and also Cyber Monday, right? So those are the two key shopping days for a lot of people shopping on Amazon. And if you want to do daily forecasting, you want to capture that. And you can do that easily by using profit model. And also Christmas, Thanksgiving. If you're trying to predict, let's say, any grocery store spend, then people will tend to shop a lot more right before Thanksgiving, right before Christmas, and the spend is going to drop during those two holidays. So you want to capture those kind of holiday effects when you build this type of daily forecasting models, and that's what profit can capture. Number 3, seasonality. So yearly seasonality, I mentioned that November, December, people tend to shop a lot more because you have discounts, and also you have all these different holidays, and you can weekly seasonality, which I mentioned, and so on. Everything can be captured automatically by profit model. And it runs really fast, that's why I can develop multiple models to capture different segments. And also it allows users to leverage business knowledge. So I'm going to talk more details about this one later on when I show Power BI visualization tool. But there are some cons. So if you have too many segments, let's say you're trying to dice the data just to capture many segments and in order to meet the business needs, then this may not work because at least the way I develop profit model is developing model for each segment. So if you have millions of segments, it may not work. And also, if there's no clear seasonality and no clear trend, any time series model may break, may not work well. So with that said, let me just walk you through what I have done to build daily forecasting models using profit. So we have this daily data. The first thing that you have to do is to change the column name to DS and Y because that's how profit model accepts the data. The second thing that I mentioned is holidays, right? So if you come here and you have to build this data frame which shows like which holidays you want to capture. It could be Amazon Prime Day, it could be something else, but basically for illustration purposes, I simply imported holiday package, and I just defined lower and upper window -2 days and +2 days. So what are they? So if you think about holiday, let's say tomorrow you're going to have Cyber Monday, then maybe your spending pattern is going to change. You're probably not going to shop today because you know that tomorrow you're going to have a big discount. Or these online merchants could provide discounts over a certain time period. So your spending pattern is going to be affected by not that on that specific holiday only, but like you have to take into account the time window surrounding those holidays. So that's what it does. But I didn't do the primary tuning, I didn't do anything fancy here. I just simply added -2 days and +2 days. Here, the third step is you have to do the primary tuning before you build this model, profit model. First thing that I do is just enter the data frame into this profit model. And second thing you need to do is you need to determine whether you want this model to be linear or logistics. Because the idea behind this growth is that not, like if you do just 1 year forecasting, maybe linear makes sense. But let's say you want to forecast 5 years or 10 years down the road. Then at some point, the company is going to plateau in terms of their revenue growth, right? So if you want to capture that effect, then you want to put logistics so that the growth is not linear, but at some point it's going to slow down. The second thing here is capturing seasonality. I just put everything auto so that profit model can look at the historical data and capture seasonality automatically. And you can put seasonality mode additive or multiplicative. If you think that the seasonality, like the effect of and magnitude of seasonality is going to same over time, then you put additive. If you think that it's going to grow over time, then you put multiplicative. The last two parameters that I put here is seasonality scale, holiday scale, and this one determines how much weight you want to put on these two parameters. So you can put higher number to emphasize that these are important and when you develop the model. So you might have to do primary tuning for your model in order to find the best set of parameters. The second one is the visualization. So profit model also has good visualization package, just like ThreeMax model. I personally think that this one is better than ThreeMax model because it shows the trend, right? It shows the trend, and you can see the forecast here. It also shows the confidence level. We can set different confidence level to forecast where the forecast could actually land. And you can look at the holiday effects, how much they are. And if you look at y-axis, it shows how important these holiday effects are relative to other effects. So, and you can look at the weekly seasonality. In this case, people don't shop on Monday, and people shop a lot during weekends. But I think this is sort of hypothetical data that I got from Kaggle website. Just keep that in mind. And lastly, the yearly seasonality, people shop a lot more at this specific retailer during summer, but not during winter. So, again, when you talk to non-technical people, you can show just simply these 4 charts. They're going to get it right away. So, I think this type of charts are good for communication purposes. So this is daily forecasting. If you look at this second chart, the blue line shows a profit forecast and black dots show actual data. So as you can see, it captures weekly seasonality very well. It captures yearly seasonality very well. And also, it captures, I don't know exactly what's going on here, maybe November holiday season, but it captures this type of things on a daily basis. So you can capture all these things, and profit model is pretty good at daily forecasting. And let me move on to the next slide. to talk about diagnostics. So when you do develop models, right, you always have to evaluate your model. And what profit model does is provide the package that allows you to do the diagnostics in a very easy manner. You don't have to do a lot of coding. You can just simply put one simple line and you can do the diagnostics in this way. I'm going to explain more details. So this chart is directly from Facebook website. So you need to define 3 time periods. Initial time period, horizon, and period. So initial time period represents your trained data set time period. And horizon represents test data time period. And you have this cutoff. And what is period? Period is when you have the data set from here, 2007, all the way to 2017, you want to do multiple evaluations. So similar to k-fold cross-validation. If you want to do that, and if you define period 1 year, then what it's going to do is do the evaluation process using this data up to here. And then, let's say period is 1 year. Then it's going to move the whole thing 1 year, shift everything 1 year, and then do the evaluation and provide you multiple evaluation results. And then you can try to understand whether a model makes sense for your business problem. The second thing that I want to mention is this rolling window. So this is also part of profit package. So here what it does is I'm using mean absolute percentage error to understand the error rate. What it does is try to look at 50 data points forecast and then measure the error rate. It's rolling window, so if you go to 100, if you're trying to predict 100 data points, this is error rate goes down and then stays the same. If you're trying to predict 360 data points, it goes up to here. So you can use this type of graph to understand where your model and how your model performs depending on which time period you choose. And you can do more deep dive analysis.
Yeah, just a quick question. Are we looking at, you modeled the aggregated time series, or did you model the individuals and then you aggregated the prediction or segments?
Right, so right now the one that I'm talking about, everything is individual, but I'm going to talk about the aggregation and how I develop the models at different segment level. So yeah, this is the slide. So far we talked about how I developed the individual time series models. But what also you can do is you have, let's say, business unit segmentation and you want to have the time series model by product and client. And what you can do is you can develop multiple Facebook profit models. So what I'm doing here is simply, I have like 500 segments based on store ID and item ID, and I developed a model, profit model, in this way, in a loop, so that I can create 5 different models, and then I can do the aggregation at the end. So that's what I'm doing and trying to do here in this loop. This may not be the best approach. It may not work. It may work better if you do the aggregate model development, but depending on what your business needs are. So if your business team saying that we need at this level, then you might want to get into the details and develop the models at this level. So for illustration purposes, I developed 500 models for this specific problem. So the next thing that I want to talk about is the visualization for your model evaluation purposes. So what I'm going to do is go to my laptop and then show you what I developed. And you can use either Power BI or Tableau for this visualization purposes. But it's definitely good in a sense that you can communicate the model results with senior leaders with just a click of mouse. And they're going to appreciate because they may not understand how all these things work. And if you show the visualization, then you can communicate a lot better. So this is one report that I created based on this specific problem. And what you see here is store level segmentation and item level segmentation, and I aggregate everything to here to show this chart. And you can actually move around and see how each store performs. For example, here you can look at it and you can just close in and zoom in and then see how the model performed against the actual. The actual shows the green line, and then this black line shows the forecast. And you can try to understand where the model is not performing well for each data point here. So I think this is a powerful tool for model evaluation purposes. Instead of just looking at statistical measures like root mean square and also mean percentage absolute error, those are good for to compare against other models. But if you really want to go deep dive, then I highly recommend you use either Power BI or Tableau or other visualization tools to understand how your models perform. And also, as you can see, you can just look at different segments, and you can try to understand where and how the model performs for each segment. And let me move on to the next one. So this one shows the model performance between actual and forecast within 1 year time period. So I developed a model using the first 4 year time period, and then the next 1 year time period I used to evaluate the model. And the top chart shows the actual versus forecast, and you can see how far they are off by looking at just top chart. Or if you look at the middle one, this one shows the difference between actual and forecast, and you will see all the differences. Like, for example, here, my model didn't really perform well in December and January, like around winter time, and I can actually do the model evaluation and actually do the model diagnostics for this specific time period. And also, the last one is just cumulative difference. So if I add all these green bars, then that's what you're going to see throughout the year. So what if I want to understand December more? And I think Tableau has also this capability, but if you simply click, and then this specific difference between actual and forecast is mainly driven by store 2 and item 28. And what if I want to go deeper? And I just simply press Control and click, and then I'll be able to do like deep dive analysis to find out where I see the error, right? So I can actually, because I built 500 models, and I want to actually do the deep dive analysis to understand which model actually hasn't performed well. And in this way, I can find out which model is the main one and the main contributor to the errors. One other thing that I want to mention is that, let's say you want to understand from November to December, like trend change, why we have this trend change. And you can simply click here and do the analysis and analyze and explain the decrease. And it's going to show you the bunch of waterfall chart that actually explains the difference. For example, here from November to December, if I look at by store level, and these are the main 5 stores that contributed to the difference. And everything is clubbed together here in this other category. So I can know, okay, the difference and trend change was due to these 5 stores. And I can do that for here, item as well. So if you have multiple dimensions in your data set, you can use this type of visualization tool easily. And also you don't have to explain all the statistical metrics to senior leaders when you just show this one. It's very intuitive. They're going to get it right away. And yeah, that's how you can perform smarter diagnostics exercise. So let me come back here. I think I spoke a little bit fast. So this is a recap of today's discussion. So we talked about how you can use machine learning models like 3D and random forest, all these things for time series problems, where I introduced techniques like using lag variables and also using distance to target column to just have one data set that can be fed into one model. But as I mentioned, there could be different approaches that you can adapt, but that's my recommended solution. The second thing we talked about is monthly ThreeMax model and also a daily profit model, and how you can perform model diagnostics using visualization tools like Power BI or Tableau, and you can communicate way better with senior leaders who do not have a lot of understanding in this model development process. So that's what I was able to do over the last 3 months, and hopefully this added some value to you guys in this session. So, yeah. Questions?
Can you add the decision variables into the profit?
So the question is whether or not I can forecast exogenous variables and then build profit model there.
Can you put the X, let's say, so a
yeah. You can when you insert, like when you build profit model, there's a you can insert exogenous variables there. So that's what I did. So if I can go back, let me see if I did it here. I'm not showing it here, but you can insert, exogenous variables into profit model. So in order to do that, when you build a model, you just need to add one more line here. Add, I don't know what it's exactly called, but add exogenous variable, and then just you can insert it.
So on the first model you were walking through, and you were talking about the lagged approach, and I don't know if this was just illustrative, but like you had T-1, T-3, and so on and so forth. I thought you would have needed more like T-12 to deal with.
Right.
So is there something I'm missing?
So this is, let me just go back to the slide. So let's say this is one big example, right? So I just, for illustration purposes, I just put T-1 and T-12, but you could have as many lag variables as you want. It's going to be feature engineering maybe for your team, because in some cases you can put -1, T-1, and that could be the most important variable. Some cases you put T-12 to capture yearly seasonality because you want to capture last year's spend and so on. So
yeah, so I'm not being clear. So you would then have to forecast that variable, would you not? So wasn't that the whole concept of the lagging?
yeah, so we are using the lag variables.
Yeah, by 1 month. So then when you use the next month,
Yeah.
you're then using, I guess, the output. Is that the?
So are you talking about multi
Yeah.
or this specific example?
When you're forecasting the full year.
A full year, got it. Yeah, so here, when I use the lag variables, these are the lag variables you can use like 1 month or 2 months. You can have as many columns as you want, but these columns in my proposed solution is fixed as of January. That's what you have over there. And just change this column, this target column to forecast the future spend.
So, and the next 12 points of your training data would be you just move one more point to February and you capture all of these particular lag variables and then all the 12 months.
Yeah, so you can develop a model once in a year, and maybe this can handle all the 12 data points forecast. But if you develop the model every month,
No. What I'm saying is that like this is one snapshot of your training set, right? Like when you're creating your training set, you would have some kind of like January history, then you would have from February you would have another 12 months, then from March, and that's how you would like slide through that entire thing to create all the training set to create this.
so one, I don't know if I understood correctly, but one thing that I didn't mention is whether this specific distance target, right? This could be, let's say right now in January, right? So this distance to target is February in this case, and this one is March, right? So in addition to these columns, you may want to create other columns, dummy columns, to capture whether this is January and February, just to capture different seasonality, yearly seasonality. If that.
I mean, my question was that, like, if you have to build this sort of a model, right? So you won't build your model using just 12 points. You would need a lot more data. So what you are showing me is just one particular snapshot.
Got it.
So that's what I'm saying, that the next, so you would have some history from, let's say, January, some particular thing to this sort of a thing, and then you'll do a sliding window kind of a thing,
Yeah,
as of January, as of February, as of March, and you'll have all of these 12 points.
Yeah.
Something like that, right?
Yeah, so you want to have like many data sets, right? And then stack them together.
Yes.
And then build the models. That would be probably ideal if you have a lot of, if you don't have a lot of data, right? Even if you have a lot of data, then if you do that way, then your data set is going to be larger, and then you should be able to build potentially better models. So you can explore different options.
Okay, I got the point now. Like, so what you're saying is that your entire thing is fixed as of January.
Yes.
But then you have CM1, CM2, CM3.
Yeah.
And for all of them, you basically like build one particular prediction model, right? Or
I plug all this entire data set into one model.
Correct.
Because we only have this distance to target column.
Got it.
Yeah. Oh, it all depends on accuracy and business needs. So my team actually developed a profit model, time series model, and this is by a different team within the same finance organization. So if you think that daily forecasting is very important, but I wouldn't actually go use this approach, then you have to have like 1 all the way to 365, right? It's going to increase the data size too large. So but in my case, what I'm doing right now is to try to understand how much our card member spend is going to be on specific merchant, right? And we want to capture all this different seasonality, and for that specific purpose, we wanted daily forecasting, and this is not really good for daily forecasting, so I use profit model for that purpose. I think, yeah.
So if you use DEM with this particular data set, how do you ensure that the nodes, there'll be a node for at least each one of those distance targets? So, for example, if you train that model and it doesn't actually lose distance, it doesn't choose distance to target as the important variable, then won't your outputs be sort of all the same? Or have you never seen that to be the case?
The thing that I have seen is that this usually comes out as very important variable. As you can see, there's no variance across these multiple columns, but you see the variance in the target value. So what usually comes out at the end is that this is going to be one of the most important variables for this specific data set. Yeah. Well, you can explore different ways and see which one fits, but usually this one comes out as the most important features.
But each of those nodes might say, is it less than or equal to 4 or 3 or 6 or 7? So you're saying eventually all of those nodes will cover splits between every single one of those, between 1 and 12?
I assume so. I don't know exactly how all the details behind how this GBA model works. I know it's a tree-based model. I think we can use it for various purposes. But what I can tell you is that this specific column came out really strong in terms of predictive power.
You mentioned that one of the ones was not predicting as well. Do you have any suggestions on how one would go about maybe fine-tuning just that portion? Rather than just changing all the parameters across the board?
Right, exactly. So if I go back to, let's say, Power BI, let me just quickly go back. And let's assume here, December is the main one that has huge variance between actual and forecast. what I do is I simply click in this specific example, and I'm trying to understand where the variance comes from. It's 80,000, right? And then 10,000 is coming from store 2. Let's say we have big number here. Then I'm moving into a deeper granular level, and then here item 50. So remember, I built profit model for each segment. That was my model development strategy. So there's going to be one model specific to this segment, right? Then I go to the model and do the parameter tuning manually. Yeah. But if I don't have high error rates, why bother? And since I have many, like hundreds of profit model in my example, I don't actually go through all this exercise. But one challenge that my team has is primary tuning for these many models. For that purpose, there are different solutions out there. I think we had a talk from Sika talking about hyperparameter tuning and so on. So we are trying to explore different opportunities to do the parameter tuning for these many models.
One of the challenges with time series models is they're pretty sensitive to outliers. How do you tackle those if you have many different models?
So outliers, I think that's a good point, but in this specific example, let me just go here. So I was trying to predict the daily forecast, and let's say we have very high spend number or very high number of items sold for this retail company. The first thing that I would do is not to treat that as outlier, and I'll try to understand why people are spending a lot more on this specific day. It could be due to Cyber Monday, or it could be due to Amazon Prime Day, or I would actually try to understand business reason and see if that's an outlier. And if I determine that that's not the case, if I can find business reason, and if I look at historical data, right? So we have yearly seasonality, weekly seasonality. If I look at historical data on exactly the same day, and if I don't see that huge spike, and to look at multiple time periods, and I see the same thing, but just one is a very, we have high spike, then I would just get rid of that data point, because that's obviously an outlier. Right? Great. Any other questions? Okay.
Great talk, thank you. I was wondering what you're doing to avoid overfitting, given that you've added lots of dimensions available.
So in order to, the question was overfitting, right? So let me just go to this profit example. So if I just, in this example, I just used like 4-year time period for my train data set, and test data set, I just use 1 year. But if I use a profit package, as I mentioned, I can actually do multiple, like similar to K-fold validation type of exercise by choosing the initial period and cutoff and horizon. So if I choose initial period here and then cutoff and do the model evaluation multiple times, let's say if I have a lot of data, historical data, if I can do the model evaluation maybe 5 times, then it's gonna look at different time periods and then try to evaluate the model based on those different time periods. So it could potentially remediate the concern related to overfitting.
So if a new shop is opened or there's a new item, how do you deal with that?
That's a good point. That's a good point. Because if there's a new store, then that's not what I'm capturing here. It's gonna be if I have to develop model, because American Express also have new cars, right? If that's the case, then I might have to do the overlay on top of the models that I have. So does that answer your question? Yeah. So basically, the model is not perfect because model only look at historical data, right? But if we have new store, new cars, or new products, then the model doesn't know. It's just purely based on historical data. So I have to do the overlay if I build the segmentation model. But if I build a model at company level, for example, then it may be already captured by the trend. So company, for example, in the past introduced a lot of new products and stores, and if company introduce these new products and stores in the future at the same rate, right, then it's going to be captured by the trend, and it's going to be captured by time series models. Good? So this is, you mean profit model, right? So usage of this model could be many. So the profit model is open source, and we can use, so I don't think there's a license attached to that model. But in terms of usage, right, exactly. So at least right now, the team that I'm on is a finance decision science team. We have to do the forecasting for the company, how much our company is going to make from different business units and different products. And if I develop a model in this way, then that's going to allow smarter forecasting for our business unit, and we can plan better for the next year. And like to his point, like if there's a new product, what's going to happen? And what if we acquire more car members, then what's going to happen? All those things could be baked into the model as results variables. So that's what we can do. Yeah, it's going to be used for business purposes, but I think that there are a lot of other sources that you can use for this type of time series forecasting.
Are some of these models or any of these ideas of time series models in production, are they actually being leveraged today by the business, and so what's the adoption that you see versus them doing some of their stuff in Excel or?
Right. So we have 3 business teams: one in charge of consumer, one in charge of merchant, and one in charge of commercial. So I have my director here. For consumer team, the models have been developed for about 2 years, and what we are using, the main reason and main purpose of this model is to do forecasting. And I think adoption by business was very encouraging, because previously we just used very simple rolling mean approach. And that's what usually a lot of finance organizations do. But once you develop the models and have this value proposition to them that you can build models, you can do the daily forecasting, you can slice this, dice data as you want, there could be a lot of usages and applications that these models could have. And they were very adaptive in terms of like using these models. But one challenge that we had is communication, because previously they had their own models, and now they moved to these new models, but we were pretty good in terms of communicating to them what value we are adding to business units.
There are many applications of this. Do you think that you would share this with the merchants themselves? Because I imagine this, the daily sales and when they're on drop-offs, they know intuitively what could be useful for their own kind of purposes.
I don't know to that question. I'll probably need to discuss with business teams whether it makes sense to share this type of data with merchants and our customers. But potentially, if there's no obstacles, then why not? But that's something that I might have to talk to the business team. Yeah. But I think it could add a lot of value if we share this type of information, because they don't even maybe know how much revenue they're going to make from American Express. And if we share, for example, daily forecasting, they can actually plan better for their business in the future. Okay, I think time is up. So if there's no question, then I'm going to end here. Thanks a lot for listening.